Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to convert YOLO v10 nano model into tflite format. Also you can use same method for converting YOLO v8 nano model into tflite format. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to convert latest object detection model into tflite format. We are going to convert basically YOLO v10 n.pt model, means the nano model, into tflite format, and then we are going to detect some object. So as I mentioned, you can use a same method for converting YOLO v8 n.pt model into tflite format also. So first, this is completely fresh version of latest Raspberry Pi bookworm 64-bit version. So this is fresh version. So first we need our packages. So just open programming and Thony. It will open our Thony Python IDE, and first just click on switch to regular mode, then click on OK and just close the Thony Python IDE. Then again go to the programming and just open Thony Python IDE. It will open our Thony Python IDE with regular mode. So now minimize Thony Python IDE. So for today's session, I have created a new repository. I will mention the link inside description box. You need to simply copy paste the link inside the web browser. Then go to the code, click on download zip, and it will download our zip format repository. Done. We successfully download our repository. Now open file manager, go to the downloads, right click to the repository, click on extract here. It will extract our repository as a folder. Now we are going to move our repository inside Pi directory. So just right click, cut, go to the home, and this is what our /home/pi directory. Just paste it our repository over here. Done. Now as I mentioned, first we are going to install packages, but for this particular version, for bookworm 64-bit version, if you want to use the pip, so you need to first run the command. So just open repository, and inside that I have mentioned install the txt file. It will open our text editor, and inside that we have some codes. So this is the first code. As you can see, sudo rm usr lib python 3.11. this is the first code line. Just copy as it is, just copy first code line, open terminal, and let me make a zoom in. I hope you all see clear now. Now just copy the first command, which is sudo space rm usr lib python 3.11. copy as it is and just paste inside terminal, and then hit enter. Now we can able to run pip command on our terminal also with the help of Thony Python IDE. If you try to run the command before this code, there will be error. So remember one thing, before starting any package installation with the help of pip, we need to run this command sudo rm /usr lib python 3, simple python 3.11. So I have copied the command and I have pasted the command inside terminal, then just hit enter. Now we are ready. Now minimize all these things, minimize terminal, minimize file manager. So now we are going to open our Thony Python IDE, but first let's just close Thony Python IDE, and now again we are going to open our Thony Python IDE. So just go to the menu, programming, and Thony Python IDE. And now here we are going to simply open our tools, manage packages, and search for opencv-python. Then click on search on PyPy, first package, and now we can simply install our opencv-python from our Thony Python IDE. Remember one thing friends, after you run this command, After you run this command, just close Thony Python IDE and again open Thony Python IDE, because then after it will take this command effect inside Thony Python IDE. Simple. So for that, simply run the command, and then if you open the Thony Python IDE, then just close it, the Thony Python IDE, and again start Thony Python IDE. Then it will take effect of this command inside Thony Python IDE. That's it. So now we search for opencv-python, click on search on PyPy, and just now click on install button. It will install opencv-python on our Raspberry Pi Bookworm 64-bit version. Of course, it will take some time. Meanwhile, I will pause video. So friends, we have done with opencv-python. Now next package, of course, we need Ultralytics. So Ultralytics, click on search on PyPy. First package, click on install, and now it will install Ultralytics on our Bookworm 64-bit version. So it will take some time. Meanwhile, I will pause video. So friends, we have successfully installed Ultralytics on our Bookworm 64-bit version. But there is error for Ultralytics on latest Bookworm 64-bit version OS. So let's just first solve the error for Ultralytics. So let me close the tools window, and here if you try to import Ultralytics from YOLO, from Ultralytics, if you try to import YOLO from Ultralytics, so let's just mention from Ultralytics, from Ultralytics we are going to call our YOLO. So import YOLO. If I hit enter, as you can see, there is error, process ended with exit code -4. So this is the error basically for torque and torque vision. So we need a particular version package for torque and torque vision. So if you open our install.txt file, so here it is. As you can see, we have done with this command sudo. So then I have mentioned the second command, which is torque this version, torque vision particularly this version, and torque audio particularly this version. We need these version packages of torque. So simply copy the command as it is, the second command, copy as it is, open terminal and just paste the command as it is, and then just hit enter. It will install torque packages with their version on Bookworm 64-bit version, which is the latest version. Simple. So again it will take some time. Meanwhile, I will pause the video. So friends, our process is completed, and if you cross check over here, here it is. As you can see, found existing installation of torque 2.4.0 and found existing installation of torque vision 0.19.0, and then it's basically uninstall all these by default torque version packages, and then we install all these packages with the version which we need. Simple. So we successfully install the torque packages. Now if we try to import YOLO from Ultralytics, so let's just call again from Ultralytics, import YOLO, and import YOLO, and if I try to hit enter, and friends, as you can see, now there is no error, process ended with exit code -4. There is no error. Simple. So this is how you can solve the error for Ultralytics YOLO. You need to simply run the second command of particular torque version packages, and just copy the command as it is and just paste inside terminal, hit enter, done. We have done. Now friends, as I mentioned, we are going to convert our .pt model, a YOLO format .pt model, into .tflite. So .tflite is basically TensorFlow. So for that we need here a TensorFlow. So for TensorFlow, first we need a package, this package libhdf5-dev. So before we install TensorFlow with the help of Thony, we are going to run this last command, which is third one command. So just copy as it is. copy it, open terminal, and let me clear the screen, and then just paste the command inside terminal. Sudo apt get install lib hdf5-dev and then hit enter. Then here simply press Y from keyboard, yes, and then hit enter. Now it will install lib hdf5-dev on our bookworm 64-bit version. So friends, we have done. Now we can install TensorFlow with the help of Thony Python IDE. So let's just minimize all these things, and again just go to the tools, manage packages, and search for TensorFlow, and click on search on PyPy. First package, just select it, first package TensorFlow, and then just click on install. Now it will take some time. It will take minimum 10 to 15 minutes because it will build a package with the help of h5py. So meanwhile I will pause video. So friends, we have successfully installed TensorFlow on our bookworm 64-bit version. Remember one thing, as I mentioned, for building package for TensorFlow, it will take some time. It will take minimum 10 to 15 minutes. Simple. So we have done with package installation. We install opencv-python, then we install Ultralytics, then we install TensorFlow. Now the last package, which is a CV zone, click on search on PyPy, select CV zone, click on install, and then it will install CV zone on our bookworm. So friends, we successfully installed CV zone package also. Now we have completed our all packages installation process. We install opencv-python, we install Ultralytics, we install TensorFlow, and then we install CV zone. Now here we need to reboot our Raspberry Pi 4. So we are going to close all these things. Just close all these things, close terminal, text file also, and I will close my file manager, then I will close browser also, and then just go to the menu, click on shutdown, and now we are going to reboot our Raspberry Pi 4 once. So friends, I have reboot Raspberry Pi 4. Now we have done with package installation. Now let's just open file manager and again open our repository. This is our repository. Now we have here t1.mp4. This is what our video file, where we have a basically car, motorcycle. So friends, as I mentioned, I have already convert YOLO10 n.pt, which is pre-trained object detection model, and with the help of pre-trained object detection model we can detect a car class, we can detect a motorcycle class. But on Raspberry Pi 4 we are going to use a nano model, which is a small model, and also we are going to convert our small model into tflite format with image size 240. So when we convert our basic model, means when we convert our object detection pre-trained model, which is YOLO10 n.pt, into tflite format with image size 240, it will not that much perfect detect all object. It will not that much perfect detect all objects. So here, let's just say from this scenario I want to detect a car and motorcycle. So here what I will do, I will create my own object detection model for this scenario, and I will mention the classes which I want to detect over here. So let's just say for this scenario I just want to detect my car class and I just want to detect my motorcycle class. So instead of converting pre-object detection model, which is YOLO10 n.pt, as I mentioned, when we convert our pre-object detected object detection model into tflite format, it will not that much perfect detect all the objects, because here I will create a tracker, or I will basically assign the tracker also, then I will create a counter. So for using of tracker we need a perfect object detection. So for that we are not going to use our default YOLO v10 n.pt model. We are going to create our own model as per our requirement. So for this scenario, my requirement is I just want to detect here a car and motorcycle class. So I will create my own object detection model, and then I will convert that model into tflite format with image size 240. Simple. So we have our video file. So here we need images. So simply inside repository I have mentioned img.py. So let's just right click to the img.py and open with Thony Python ID. It will open img.py with the help of our Thony Python ID. As you can see, this is what our img.py. So here simply this is what our video file. So here let's just mention the video file name, which is t1.mp4. This is what our video file name. You need to simply mention your video file name as per your project. Of course you can use here web camera also. So instead of mentioning the video file name, you can simply mention the index number of camera. You can mention 0, 1 as per your index number of web camera. Simple. So right now we are going to use our video file. So for that we are going to mention our video file name, which is t1.mp4, and the frames which we are going to use, let's just say 140. For this scenario 140 maximum frames is enough. You can simply mention 1000, 2000, 500, 50, 510 as per your project requirement. So I have mentioned here 140 images. So then we are going to save our images inside the folder. So inside our repository where we have img.py, our video file, here simply create a new folder and mention the name images. So right click, new folder, and images. Click on OK. It will create images folder. Now right click to the images folder, copy the path, click on copy path, minimize, and here from images just remove back way, go the back way. Simple. Just remove it and then press Ctrl+V. It will paste the path of our folder images which we just copied. As you can see, it's copy, and then img is basically the image file name and .jpg is extension. So now it will save all the images. It will save basically 140 images from our t1.mp4 file, and it will save images inside /home/pi YOLO10 tflite -raspberry pi -main images folder, and inside that it will save the name img and .jpg extension. Simple. Now let's just save the code, and if I start the code, it will start our video file. It will capture 140 images from video file, and it will save the images inside our video file. Oh sorry, inside our folder. As you can see, done. So if I open our repository, if I open images folder, as you can see, there is all the images. Basically there is 139 images. So if I right click to the one image, and friends, as you can see, as I mentioned, this is what our all images from video file. Now we are ready, and friends, here we are not going to use label img software for training all those images. We are going to simply use auto label. So we are going to basically use auto distill, where we are going to automate our labeling process. We are not going to use here a label img software, but you can use label img software. Also you can use RoboFlow for training your images. Simple. But here we are not going to use RoboFlow. Also you are not going to use a label img software. We are going to use auto distill, which basically automate our labeling process. So for that, let me open Google Colab. So friends, as you can see, I have opened Google Colab. Now here we are going to upload our Colab file. So just click on upload, click on browse, and inside that repository I have already mentioned the Colab file. So go to the home, and this is what our repository, and as you can see, this is what our Colab file. Auto label YOLO10 tflite.ipynb is. Just select it and click on open. It will upload our Colab file on our Google Colab machine. So friends, we upload our Colab file. Just go to the runtime, change the runtime type, select Python 3, select for GPU, click on save, and then just click on connect. Now as you can see, it's connecting. So friends, we successfully connect with our GPU. Now let's just run our code one by one. So let's just start with first code, import OS. Done. Now we are going to create here images and dataset directory. So let's just run our next cell. And then we are going to install auto distill, grounding Dino, supervision and RoboFlow on our Google Colab machine. So let's just run our next cell. So just click on the next cell and it will install all those packages. So friends, we successfully install all the packages. Now we need our images. So here if you click on this folder icon, we have here images folder. So inside that folder we want to upload our all those images. So images folder, here it is. As you can see, we have 3 dots. Just click on it, click on upload, and now it will open our local file accessing window like this way. So now simply go to the home, then go to the repository, go inside images folder, and we have our all those images. Just press Ctrl+A, select all the images, click on open, and it will upload all the images on our Google Colab machine. As you can see, it's uploading. Here we want to simply click on OK, and now our all images, our all 139 images is basically uploading inside our images folder. So it will take some time. Meanwhile, I will pause video. So friends, we have done with uploading all our images. As you can see, now inside images folder we have all our images. Done. Now let's just scroll down our code, and then we are going to run our next cell. So just click on next cell. Done. It will basically mention the path of our images and dataset folder. Then now here we will get the idea how many images basically we have. So we have basically 140 images. Then run the next cell, and then again run next cell. It will show all the images. Simple. As you can see, we have all the images. That's it. Now just scroll down, and this is what our main code. This is what our main code, where basically auto distill with the help of grounding Dino, it will detect the classes which we are going to mention. So here, as I mentioned, for particular this video, I want to detect a car class and I want to detect a motorcycle class. So here I will mention in double quote, mention car. So this is basically prompt, and then this is the main class. So prompt is also car and class name is also car. Then our next class, so mention comma, again double quote, and here I will mention motor cycle, which is prompt, then colon, space, again double quote, and here again mention the class name, which is motor cycle. Double quote car, this is prompt, then colon car class, motorcycle, in double quote, colon double quote, motorcycle. This is the class. Now we are ready, and it will now detect the car and motorcycle from all our images. Now let's just run the code. Friends, we have completed our process. As you can see, now just scroll down, and the next code is basically where we mention the dataset folder. Inside that dataset folder we have now train and valid folder. Dataset folder, as you can see, we have here train and valid folder, and inside that we have labels and images folder. Also here we have data.yml file. So this is basically path. So let's just run the next cell. Now run our next cell, where we can see the result on our images. Done. Now here, as you can see friends, we have a rectangle on motorcycle class, also the red color rectangle on car class. So we have basically green color rectangle on motorcycle and the red color rectangle on car class. It means AutoD still perfectly detect our class. Simple. So now we are ready and we are going to use our data.yml, and with the help of Ultralytics, as you can see, now we are going to install Ultralytics. So with the help of Ultralytics, here it is. With the help of Ultralytics YOLO10 n.pt, which is pre-trained object detection model, we are going to create our own model which detect our highlighted classes, which is car class and motorcycle class, using image size 240. So because we create our own custom model, it will detect a perfect class. But here what we will do, because we have our YOLO10 n.pt model for creating the custom model, so of course it will download the basic model also. So we are going to convert our 10n.pt model into tflite format also. We are going to we have of course our custom detection model, so we are going to compare the both model. Simple. So let's just first install Ultralytics. So if I run the cell install Ultralytics, as you can see there is error. But why this is error? Here simply we want to restart our session. So just go to the runtime and click on here restart session. Just click on restart session, click on yes. It will restart our session and then we can install Ultralytics package. Now if you try to run the cell, as you can see now it's installing the package. So friends, as you can see we have done. Now as I mentioned, now it will use our data.yml file with 100 epochs, image size 240. Now let's just run our code. So friends, as you can see, process is started, 1 out of 100 epochs. So it will take some time. Meanwhile, I will pause the video. So friends, as you can see, we successfully completed our training process and our model is basically saved inside runs, detect and train. So if I go here, runs, detect, train, then weights folder, and then we have our base.pt. Now let's just cross check our base.pt model. So here I have mentioned the code. It will use the base.pt model. Here it is, as you can see, the path, and then it will use our image from images folder. From this folder, inside that folder we have our all the images. So it will basically select the image from image 36 number, and then it will use a base.pt model and it will show the it will basically save the result. So let's just start our code. And as you can see, result is basically saved inside predict folder. So we have here runs folder, then we have detect, then we have predict, and then inside that we have our image which we use, image 36. And as you can see, there is a result. It's detecting perfect car, motorcycle and car class. So it's detecting our all the objects. Now as I mentioned, now we are going to convert our model into tflite format. So here it is, as you can see, here I have already mentioned the path, so there is no need to change the path. So let's just convert our model into tflite format. So let's just run the code. So friends, as you can see, the process is completed. It means we have our model ready. Now if you scroll down the code, the model is basically saved inside train weights, and inside that it's create basically base save model folder, and inside that we have our model which is base float float32.tflite. This is the model name. So if I just click on again runs, here we have detect, we have trend folder, we have weights folder, and inside that we have base save model folder. As you can see, base save model. So just click on it, and then we have base float32.tflite. This is what our converted custom object detection model. Simple. Now let's just download our first custom object detection model which we just create. So just click on download. Now it will download our model. Then we are going to convert our basic model also, because we have our basic model. If you just click here, as you can see, this is what our basic model, because we use yolov10 n.pt, so it means of course it will download the basic model. So for cross checking, for comparing, we are going to convert our yolov10 n.pt model into tflite format also. So we download our custom object detection model. Now this is what our converting code. So here I will mention the path. So just this is the model. So just click on it, copy the path, and just remove the base.pt path, remove it, and press Ctrl+V in double quote, press Ctrl+V. It will copy paste our yolov10 n.pt path. And because this model is basically this is basically default model, so it's come with 640 image size. So here I will mention the image size 240. So here after format, comma, imgsz is equal to 240. This is what image size. And if I start the code, now it will convert our basic model yolov10 n.pt with image size 240. Here it is, as you can see, it's mentioned the 256 image size. So it will convert our basic object detection model into tflite format with image size 240. Simple. So friends, we have done, and our model is basically saved inside. It's again creating a new folder, yolov10 n save model, and the model name is yolov10 n float32.tflite. So if I just click here runs, as you can see, there is a new folder, yolov10 n save model. So this is the model. This is basically basic model, pre-trained object detection model. Just click on it, and inside that we have, as you can see, yolov10 n float32.tflite. So this is basically our pre-trained object detection model. We already download our custom object detection model. So let's just download our pre-trained model. Download. It will download our model. As you can see, we have now our both model. Now friends, as I mentioned, same method, with the help of same method you can convert yolov8 n.pt. Simply here you need to mention yolov8 n.pt. Of course you have the model. Here it is, as you can see, we have our 10 n.pt model. Same way we have our 8 n.pt. So just copy the path, run the code, and it will convert your basic model also into tflite format, which is yolov8 n.pt. Done. So we have our all models ready. So let's just open our download folder, because by default our model download inside our download folder. So we have our best custom object detection model, we have our yolov10 n means pre-trained object detection model. So copy all those model, cut, go to the home, our repository, and just paste it. Then now we are going to open our main.py with the help of Thony Python IDE. So I have just opened default way. Let me open with Thony Python IDE. Right click and Thony Python IDE. It will open our code with Thony Python IDE, as you can see. So here I have mentioned the custom object detection model. Let's just mention our first pre-trained model, which is yolov10 n. This is basically our pre-trained object detection model. So here simply right click to the model and click on rename, and just copy the name, copy it, and then just cancel and open Thony Python IDE, and here mention the name of our model. Done. And then here we will mention coco.txt. Done. Now then we have our basic object detection. Now we are going to start our code. So friends, as you can see, I have started the frame and there is a detection. This is, as I mentioned, this is basically pre-trained object detection model. This is not our own model which we create. This is pre-trained object detection model, and as you can see, detection is not that much perfect. Detection is not that much perfect for tracking the object, for creating the counter. Simple, it's detecting the motorcycle, it's detecting person also, it's detecting car also, but we need for tracking object, for creating counter object, we need a perfect object detection. So for that we create our own model with two classes, which is basically car and motorcycle. So as I mentioned, so we have tested the basic object detection model. Now we are going to simply cross check our own object detection model. That's it. So now let's just stop the code. Here it is. As you can see, it's detecting bus also. So now we will mention here our own model. So this is what our own model. Right click, rename, then copy the name, cancel, and mention the name of our model here. Ctrl+V, save the code and run the code. Now it will use our own custom object detection model, but I forget to mention here our own label file. So here I will mention coco1 because we have only two classes. So coco1, and I will create inside repository a new coco1.txt file. So new file and coco1.txt. This is what my file name. And where is the file? coco1.txt. Right click, open as a text editor, and here I will mention the two classes. So first one is car and next one is motorcycle. You can simply cross check the classes with our data.yml file. So here it is what our data.yml file, and here we have our first class is basically car and motorcycle. So no problem. So I have mentioned same way, car and motorcycle. So just file, click on save, close the file, minimize all these things and run the code. So friends, as you can see, this is what our custom object detection model result. It's really good. It's really good, as you can see, and because this is the tflite format, so it's really working fast. Remember one thing, it will work more fast because right now I am recording at the same time, so that's why it's little bit slow. But if there is no process of recording and any other heavy process, it will really work fast because we convert our model into tflite format. As you can see, the detection is really good. So now we have done with our own custom object detection model result. Now simply, as I mentioned, inside repository I have mentioned main1.py code where we have our counter also. So file, open, and main1.py, and here I have mentioned full code with counter. So this is what our model, and let me first stop the while loop. So I have already stopped the while loop. If I start the code, so friends, as you can see, this is what our tracker and counter model, and then we have our tracker. So inside that repository I have mentioned the tracker.py also. So where is tracker.py? Here it is. As you can see, tracker.py. Simple. So with the help of tracker.py, it will assign the unique ID for each object. So we have here car class, we have here motorcycle class. So as you can see, there is a motorcycle detection, there is a 1 for this motorcycle, there is a 7, and for this car we have 3 ID. So what is the concept? With the help of tracker, we are going to track the object, we are going to assign the unique ID for each car, each class basically. For car class, for motorcycle class, only we have 2 classes, and then we are going to draw a line. So here it is. As you can see, I have drawn the line with the help of cv2.line function. If I scroll down here, as you can see, cv2.line function. So how to draw the line? Simple. If you move your cursor on the frame, here you will see there is xy coordinate. So if I move my cursor over here, it will mention the xy coordinates 235 227. So here it is, as you can see I have mentioned 236 226. so if I just move my cursor over here, again here 1018 227, here you will see the xy coordinate of your particular cursor points. Here it is 1018 226. so I have mentioned 108 226. Simple. And remember one thing, here you need to mention the y coordinate same as both coordinates. Means if you mention the start point of y coordinate 226, so you need to mention end y coordinates also 226. so this is basically start point of xy coordinate, and this is basically end point of xy coordinate for drawing line. So I have mentioned here 226 start point y coordinates, so I need to mention same end point of y coordinate 226. That's it. And then this coordinate which I will mention as a cy1. cy1 is basically 226. cy1, because cy1 is basically assigned for the line 1. cy1, so 226 is basically my cy1. cy1, then offset is basically 10. Then here in the frame, as you can see, we have basically a center point for each class. So how do we get the center point? Here, because I have already explained how we use our tracker in several previous videos, so you definitely know that when we want to use the tracker, of course we are sending our object detected rectangle coordinates to the tracker with the help of list. So here, as you can see, I have created here a two list, because here we are going to detect both classes. So for each class we need to create a separate list. So here I have created a car class. When we detect a car, it will save the rectangle coordinates inside the car list. When we detect a motorcycle, it will save the motorcycle rectangle coordinate inside the motorcycle list. Then if we detect the car, of course here it is, as you can see, car dot append, it will append the x1 y1 x2 y2 inside car, and motorcycle it will append x1 y1 x2 y2 inside motorcycle list. And then we are going to use our tracker. So for each class we need to create separate tracker. So here I have mentioned tracker, and tracker1 is equal to tracker. So we are going to use the tracker for car class, we are going to use tracker1 for motorcycle class. Simple. So then bbox idx is equal to tracker dot update. Inside that we are going to pass our car. So it will only assign the this bbox idx variable only assigned for car class, and then bbox idx variable with tracker1 dot update, it will only assign the unique id for motorcycle class. This is how we can track each class separately. We can basically track car class, we can basically track motorcycle class separately. That's it. Now simply we are going to use for loop. So for bbox in bbox idx, this is for car class, then x3 y3 x4 y4, and then it will assign the unique id. So as I mentioned, when tracker will get the rectangle coordinates, it will again track that same object, and it will again assign the new coordinates for rectangle also along with the unique id. For that we need again variable. So x3 y3 x4 y4 is basically our new rectangle variable coordinates along with the id is equal to this bbox. Simple. It is really simple. Then as I mentioned, here you clearly see we need a center point, because what is our condition? Our condition is we create here a line. So when the object rectangle center point touch our line, then we are going to count our object, then we are going to track the object. Otherwise there is no need to track the object and nothing, because here it is, as you can see, this motorcycle is already crossed my area, so there is no rectangle, there is no detection. When the object center point touch my line, then only we have detection. That's it. So for that we need center point. So how do we get the center point? Simple. Cx and cy. Cx is basically x3 plus x4 divided by 2. Cy is basically int y3 plus y4 divided by 2. Simple. This is how we will get our center point. And then we are going to mention our condition. If cy1 is represent our line 2 to 6, means our line coordinate. So cy1, if it is less than this cy3 plus offset, and cy1 if it is greater than cy3 minus offset, then we are going to draw the circle, we are going to put the id, then we have our rectangle, and then we are going to create our counter. So what is our counter? Our counter is basically detected object id, detected object id. So when our condition match, in that time we are going to save that particular id inside that our list. So here I have create a counter list, car counter, inside that it will save the id, motorcycle counter, it will save the id when our condition match. So here we have our condition, and then it will, of course, basically we are tracking each class separately. So when we say that we have motorcycle class, so inside that motorcycle id class there is only motorcycle id, there is no car id. When we say that we are tracking car class separately, so if we create a car detection id, so it means there is only car detection id when we match our condition. It is really simple, done. So here basically what happen, when the center point crossing our line area, it will take some time, so it will basically count the same id again and again. So for that we create here a condition. If motorcycle counter dot count, what we are counting? We are counting the id. So id 1, please don't count same id again and again. So this is the condition. If motorcycle counter dot count id 1 is equal to 0. So this is basically for motorcycle. Here it is, as you can see, motorcycle, and this is basically for car counter. Simple. If you study the code, it is really easy. Done. Then we simply mention the new variable and then the length of our car counter. Inside that car counter we have our id. So the car counter is basically the list. So the list of length is basically our counter. So for that I have mentioned the two new variable. cc counter is basically car counter, mc counter is basically motorcycle counter. You can mention any variable. And then length of car counter list and length of motorcycle counter list, and then I have put these two variable with the help of switch on put text method. I have mentioned the both variable on our frame. Here it is, as you can see. That's why the car counter we count here one car. As you can see, when the car center point touch my line, we have counter. We count one car. We count motorcycle 2. As you can see, there is two motorcycle which already touch our line, so we have two counter. If I press the skip button, these two motorcycle detected, we have m counter is basically for motorcycle, so we already count two motorcycle, then we have now two motorcycle, so the counter is increased, now it's 4. Watch, this car center point touch our line, now we have 2. So now we are going to start our while loop. So friends, as you can see, our frame is started and is working perfectly with our condition. When object center point touch our line, it will increase each class counter. Simple. So this is how, friends, with the help of YOLO v10 you can create your own model. Also you can convert your own model into tflite format. Same method you can use for YOLO v8 n.pt model also. So I have mentioned the full code. We will meet our next video. Till then, thank you, take care, and bye bye.